Hi. So I recently interviewed at Microsoft, and things didn't unfold as I wanted. Yeah. One is because I was not very prepared. Two, my familiarity with most of the patterns of data structures and algorithms was a bit off. But nonetheless, I gave it my best, answered a couple of questions, and yeah, so I got to learn a lot from it, and that's why I decided to like share with you how the process of interviewing is like, how you expect the questions to be structured, and such kind of things. So yeah, I'll just walk directly into it. Let me just turn this camera off, and then we get started. So the interview flow is as follows. Or before we talk about the interview flow, what we'll be covering is one, the five-stage interview timeline. Depending on the interview you are currently at, it would take different times. And then two, we evaluate the criteria the interviewers use. Then talk about how interviews differ by company type, for example, but this won't be in depth. And then what signal means and why it matters. Okay, so this is the interview timeline. Depending on the company, you might get 45 or 60 minutes. But I guess 45 is sort of like the standard in terms of like the interviews. So what you'll find yourself in is you'll find yourself in that technical interview. They'd want you to do some questions, yeah. So I want you to visualize this picture, yourself in a Zoom call or an interview room if you're doing a physical interview. Here's exactly how those 45 or 60 minutes would unfold. One is you have the introduction bit. So you'd find the interviewer saying the following. So let's take the example of a lady. So she'd say, "Hi, my name is Beris. I am a senior engineer on the payments team," for example. They'll talk about the number of years they've been in that company, and then tell you that we're taking 45 minutes, for example, to go through a coding problem together, and also ask you to code in a language of your choice. So mostly you just like work with whatever language you're comfortable with, and then you discuss the approach. Sounds good? Now, your response should be warm, of course. And by warm, I mean sort of like have not cramming a framework, but you could say something like, "Great to meet you. Sarah, I'm excited to be here. I'm comfortable with Java, so I'll use that today. Looking forward to diving in," for example. And yeah, that's how you introduce yourself. No, just like a follow up on the same, and then you could introduce. It's very important for you to introduce yourself, give a background, talk about the frameworks and languages that you're very comfortable with, a few things you've achieved in your career, etc. And then you'd be good to get started. So even though it's like 5 minutes, the interviewer is already evaluating the kind of person you are. Within those 5 minutes of introduction, what they're looking for is your enthusiasm. Are you excited to be in that interview room in the first place? Your level of professionalism. Are you composed and articulate? And also very important is your communication. Can you express yourself clearly? And the tip that I've learned in some time now is to smile. That's very important. To take a breath, and it's not like it's an interrogation or something. It's sort of like having a conversation with your future colleagues. So you have to treat them or treat the interview that way, and then I guess you'll be good to go. That is for the introduction bit, and then the other bit now is warm up. This is just like introduction to the problem. So what you get here is typically a warm up problem. So think of it like stretching before a workout. So again, this depends with where you are at. Again, the others you could just go direct into the main problem, and then you start coding it out. So yeah, this could happen because like ideally mine I just had like three questions for the first interview, which was crazy. Yeah. So the interviewer wants you to succeed, so they are gonna give you something relatively easy to build your confidence and get you talking. So yeah, they're just like building that confidence in you for the warm up. So the warm up questions would be something like very simple questions, reversing a string. They want to see how you quickly wrap your head around such a question, checking if a number is prime, finding the maximum element in an array, for example, and then checking if a string is a palindrome. Okay, so let me show you what this looks in practice. So yeah, you just like given that is for the warm up stage. You ask, say for example, reverse a string, and then the interviewer would say something like, let's start with something straightforward. Can you write a function that reverses a string? So what you need to respond, you also like need to learn how to respond to these questions, and yeah, you definitely have to practice for it to come out naturally so that you don't sound like a robot. It's very important. You could come up with something like, sure, so I need to take a string input and return it reversed, and then you need to ask clarification questions before you even start diving into that problem. So you could say something like a quick clarification question: should I handle null or empty strings? And most of the times when you ask such kind of questions, they'd say, they respond with, that's a very good question, and then they give you the follow up in terms of like answering your question, like, yes, return an empty for empty inputs. And then from there, you start like coding it out. But before coding, you start by explaining your flow, and you could do it as fast as you can, but just like walking them through your idea, or the algorithm, or the process you take to work on such a question. So yeah, that's that for the warm up bit. And then now, if and like I said, this could be combined. You could have the warm up and the main challenge as a thing, just like one thing on its own. Instead of like the warm up question, you just like get the main challenge or the main question. So yeah, I won't talk about the warm up question, but just know that's how it would look like. And for this, like you giving the warm up question, you sort of like apply the same principles when handling the main question. Talking about the performance of your algorithm that you've worked on, picking a very small input, and then walking the interviewer through the process of how that input would be manipulated to achieve whatever it is the function wants to get. And yeah, so that's how you'd start. You could start with a very bad algorithm, or and then improve it, uh, or just like have explain how the poor solution would work, and then come up, just code out the optimal solution. That's how you'd say, for example, approach it. So yeah, that's how things would look like. Talking about time complexity is very important. You have to walk through the interviewer through the time complexity, space complexity, and explain why it's giving such complexities. And if it your solution has a bad complexity, yeah, you just like need to walk them through how you'd better the solution to come up with a better uh, time complexity. Yeah. Yeah, even on an easy problem, you can hurt your chances if you don't follow good practices. So by good practices as well is you're not silently coding, and you just like engaging the interview as much as possible. Cool. Now we'll move on to the next one. After the warm up problem is now the main challenge, now the thing that brought you there. So this is sort of like the heart of that interview. Don't waste a lot of time on the warm up interview. Go as fast as you can on it if it's provided, and if it's not provided, then you can just like you already have the main challenge on the plate. So the warm up is just like to build your confidence, and then from there you're actually being evaluated. So you'll spend 25 to 35 minutes, depending on the interview framework, on this problem, and it will be either a medium or a hard difficulty. Yeah, so here's what the main challenge, this one, sounds like. So the interview will give you the problem. They have their way of presenting the problem. They read the problem for you. Say, for example, they get a question like, you're given an array of integers and a target sum. So let me just, I have this in a doc. Now let's go through this one. I'll just introduce something here, and then yeah. So you get something like this. You're given an array of integers and a target sum. Find two numbers in the array that add up to the target. And then what you're supposed to do is you return their indices. you can assume there's exactly one solution, and you can't use the same element twice. So that's how they do it. They read the question for you, and then this is where the 10-step framework would apply. But you'll just sort of like learn it later. Yeah. Now, after they read out the question for you, at least what I did is I just like asked them to do it again for me, because I was a bit tensed, and I sort of like I'd lost them throughout the way because of the tension. So you don't feel tensed. Okay, it might happen, but once you get like you didn't get the question, you could ask them to repeat the question again, and then they might give examples and such kind of things. Now, um, the next thing inside this main challenge, because I said this is very important for you, is how you respond after getting the question. So you could say something like, okay, let me make sure I understand it. Just like you reread with your own understanding, so that the interviewer could sort of like ensure you are in the same page, and how you translated the question is how it is expected for you to handle it, for example. So let me make sure I understand it, and then you reiterate, say like, I have an array of integers and a target sum. I need to find two numbers that add up to the target and return their indices. After that, it's very good for you to ask clarifications if you have any, and it's good for you to have, because you definitely would have, because this is sort of like an open-ended thing. Ask questions like, can the array contain negative numbers? Are the numbers sorted? So these are sort of like things that would um, trigger the edge cases for your for the algorithm that you are to write. So what should I return if no solution exists? Though you mentioned there exists only one solution, can I modify the input array? Because there are people who would want to sort it and such kind of things. Yeah. Uh, after you ask these questions, like I said, the interviewers would definitely respond with good questions, for example, and then they give the clarity. Say, for example, the array can have negative numbers, it's not sorted, there's always exactly one solution, and yes, you can modify if you need to. Perfect. So I'm just like giving you a framework that you could use in handling these questions, and then from there, you start now airing your views, and do not think through the solution on your own. What you need to do is you need to involve the interviewer throughout your whole thinking process. Very important, yeah. Now, you start with the brute force, of course, and then after the brute force, you sort of like explain your optimized solution. It's not compulsory for you to code your brute force solution. You just like need to explain how the brute force solution would work, and then later on, you could now code out the optimized thing. And you have to remember that this happens within a maximum of 30 minutes within the same, so that you don't waste your time and end up like Ian did. Now, you'd say a framework like this. So the brute force solution would be to check out every pair of numbers. So you just like have, you just need to have a pair of numbers, because you need to add two numbers to get the solution. And then that's two nested for loops. And then for each element, I'd check if any other element sums to the target with it. That's O of n squared time, and O of 1 in terms of like the space complexity. That's how you'd say, for example, approach this problem. Uh, and by this I mean, you could say what you're doing is you're creating sort of like a for loop. You just like create two loops. Uh, you create two loops, and then inside this other one. So this is, for example, how you'd say you're approaching this. You're creating two nested loops. So this is the outer loop. This box is, for example, references the outer loop, and then this one represents the inner loop. So the outer loop would sort of like hold the first number, and then the inner loop would hold the second number, and then you keep on iterating till you get the sum that you intend to have. And once you see a for loop, for example, this sort of like directly translates into a complexity of O of uh, okay, it translates to a complexity of n squared. Yeah, yeah. This is definite. Like once you iterate within two loops, that's a complexity of n squared. And yeah, that's how you walk through the process. And then now, after talking about the brute force technique, for example, is you now take the interviewer to how you think you'd better the solution. Now you say I can optimize this, and then talk about the key insight is for each number I'm looking for its complement. Now you introduce a concept here, and then as you explain these things, it's also very important for you to uh, to to write them out. So for every number, you see you're introducing a complement for every number, and then that's and then you also like say, and then this complement would be something like the target minus the current number that we are at. So yeah, current number, something like that. So this would be how you get the target, the complement, for example. Yeah, that's how you get the target. So let me just erase this one. Oops. Yeah, so I'll just have to redraw this one here. It's so big. Okay, this makes sense. No. Yep, yep. And that would be a compliment. This is how you walk the interviewer through your thinking process. And then after that, say if you store these numbers that you've seen, say you get you're getting a compliment, and then you have the target minus the current number. So you store these numbers. You store these numbers in, say, for example, a hash map or something. So what you're ideally talking about here is you introduce a map that you store the numbers that you've seen. So I can check if the complement exists, and then if you're checking from that hash map, so what you're introducing here is you're introducing the concept of a map. So what this map is storing is this number. You say target minus this current number, and then check in your map. Does your map contain this current number? It doesn't. So you come and then you store the current number there, and then you store its index, which is, say, something like I. So the next time you perform the operation, say your target minus the number that you'd be currently in, and if you subtract and then you get it, that number exists in your map, you need to return uh, the indexes or something like that. Okay. Now, after that, after explaining the whole thing to the interviewer, the next thing is now sharing your approach in clear statements. Now, like something, I'd create a hash map to store numbers and their indices, and then you iterate through the array. For each number, calculate the complement, which is target minus number, and then if the complement exists in a map, return those two indices, and then otherwise add current number to the map. That's very perfect. Okay, that's how you say, for example, explain the whole thing to the interviewer. So again, I have this as well, so I'll just paste it somewhere here, so that you also get to see it, and then you'd select this. Yeah. So it's, so let me just say, okay, it's not formatting the way I want. But yeah, this is how you sort of like explain it. You create a hash map to store the numbers and the indices, iterate through the array. For each number, calculate the complement, which is that, and then if the complement exists, return the two indices. Otherwise, you sort of like add the current number to the map. And now, after that, now you come and explain the time complexity. Look at how you are approaching the problem. Of course, you're creating a loop to loop through the numbers, and then because it's a single loop, and at the very worst case, that means you'd have to iterate through the whole array if you don't get like the target. That means that you'd have to iterate through the loop n times. And how do I say this? So so you have something like this. You have a for loop, and then here is just like the from where to where. You just like create that, and then yeah, something like this. So for the very worst case, so you say here the complement is something like the target minus the current number, and then yeah, you just like perform some operations here, which each operation would sort of like take an O of 1, and then because we're iterating n times, it means that it's gonna be n times. You add, say for example, you were to look for the complement, and then here you're supposed to like return something. You sort of like to return a thing, but we'll talk about this complexities in future, don't worry about them. So you're supposed to return, so this one will take O of 1 as well, O of 1 as well, and then you have this 1 plus 1 is sort of like a 2, and then 2 times that, this one would give us a 2n. But because it's complexity, we don't care about the constants, so this would result to something like O of n. So this is O of n, like that, because of that. The other complexity you need to talk about is the space complexity, because you're introducing a map, which is like a hash map. And then for the very worst case, this means that our map would have to store all the numbers, all the numbers, all the numbers. So this means that our space complexity as well would sort of like be an O, sorry, would be an O of n as well. That is the sort of like the trade-off. And then the interviewer would respond, and then from there you just like have to code out the solution. So to code out the solution, I'm not prepared to do this. Let me just open an online IDE. I'd say an online Java IDE. Yeah, let's just use this one. I hope it's a good one. Yeah, it looks good. Yeah, and you have to prepare yourself, because you might not have the autocomplete and everything, so you have to prepare yourself for such scenarios. So you'd say something like this. You come and create your method, public static, uh, public static, and then it's supposed to return an array of integers. So you have an int, and then you call the name of the problem is to sum, and then what you're getting as input is you get an array of nums, and then you have an int target, for example, like that. And then from there, you just like do this one. I don't know if I could make this one whole screen. Yeah, I'm not sure if I could make it. Yeah, let's just be here, and then no, so let me just have it as vertical. Yeah, okay, let's just work with this one. So the first thing you said, you talked about the edge cases, so you have to check if they are empty. So if nums say equals to null, or nums dot length, nums dot length is say less than 2, you say, and by this I mean you only have a number, or yeah, just like you have a number, or what, if we just say nums is less than 2, so that means it's just like one number. So what you need to return is an empty array, a new int, and then like that. That's the empty array. And then after that, now we create our map. And here what you do is you just say map, and then you're mapping, you're storing the integer in integer, and then the index as well, which is an integer, this one, like that. And then here we could just like call it our map, and then equals to our new hash map, like that. After doing that, we now iterate. So we need to also say here our map is storing the number and the index. So the key is the number, and then the value is the index. So we need to create our for loop for, and then you're looping through int the index starting from 0, and then I less than, say, nums.length, nums.length, like that, and then we increment it like this. Yeah, so this one has a lot of adds, but it's still okay. So after that, we need to now get the complement. So our complement equals to the target minus the nums at this index that we currently at. And then after that, we need to now check if our map contains, check if contained in our map. And how we check that is we say if map.contains, if it doesn't, the number, the number, if it doesn't contain the complement, this solution, this complement, we just, okay, if it contains that number, what we need to do is we need to say map.get, no, we're supposed to return an array, so we say return new int, like that, and then what it would now contain is map.get, we do map.get, sorry, map.get, and then you pass in the complement. Now this means it would get the value that this complement is in. So this is the complement, and then this would be the index. So map.get complement, it would return the index, that is our first element, and then the second thing you're supposed to add there is the current index that we are in. And then after that, what if it doesn't contain? If it doesn't contain, we just like put the num there. Say map dot put, this number is not there, so we just like put the nums at I, that's our current number. And then after that, we put the key and the value. So the value is I, like that. So I guess that's how you do it. And if you loop through and you don't get whatever it is you wanted, you just sort of like return a new int like this, and then like that. Yeah, that's how you'd, say, for example, approach this problem. And then after writing out the solution, you walk the interviewer through a sample problem. So I have this int nums equals to, we just like create that array like this, and then I'll just bring it this one. I'll just bring this numbers here like that, and then we say that our int target is a number like 9, yeah, like this. So I'll just say int solution equals to, I call the toSum, and then pass the nums, and then after passing the nums, you pass your target, and then like this, and then you just say something like a system dot out dot print line. Okay, so it's completing, yeah. And then you just like do something like that. So I hope this one runs, but you yourself, you don't have to run the problem first. So there is an error. I need to perform the imports. So import let me see, import so I'd say import, is it from the util class, java dot util. Let me just import the whole thing. I don't want to suffer. Yeah, I think this should run now. So it's nums and then the target cannot be converted to int. Nums nums oh yeah, in solution is an array. Yeah. Yeah. mm, okay, let's see. I don't know why it's not doing. So let me see, arrays dot to string and then do a sol there. Yeah, this should work now. Yeah, you get 0 and 1. Yeah, so this means our algorithm is working fine. So what happens is, you have these numbers here, but ideally was not to explain the solution, but you need to figure out how you'd sort of like break down the solution to the interviewer. So we create our map, yes, and then we iterate through I. So the first one would nums at I, which is our current num, which is 2. So you say target minus nums at I, and then you'd get something like a 7 here, for example, and then we check if the complement 7, we check if 7, this complement 7 is in our map. If it's not there, because at first it's just like empty, we add it. So this means that our map would now be having something like this. Would be having the key value, which is now the 7, and then it has the index 1, like that. No, it would have 0, 0, like that. So no, map.get, it's not there. Sorry for the wrong explanation. So if it's not gotten, so what it will do is do this. It would add the nums at I, which is the current number we are at, 2, and then the index is 0. And then come to 7, check, get the complement. When we do the 7 one, we get a 2. We check if this complement is contained. So yes, it's contained. And what's the index? So we say map.get complement, map.get. So it would have something like this, map.get, and then you pass your complement. Complement is 2, and then what is our index? It's 0, so we get that 0. And then we also add the I, so the I, which is our current index, which is 1. And that's how you sort of like break down the solution to your interviewer. And yeah, that's the sort of like the framework. And then after this is now the follow-up questions. After you explain how your algorithm is working, the interviewer would ask questions like, what if the array is sorted? Could you solve it differently? And then you sort of like provide your solution. And then as you provide your solution, talk about the time complexity as well. Say, for example, if it's sorted, you'd start with um, 2 pointers approach, for example, solve the question. Yeah, and that's how you get hired, because you need to have ticked the boxes. And oh, I duplicated this one. So follow-up questions, yes. So we've done this, we've done that, done that. So this sort of like the same thing. And then here is now another very important thing. If it's for like an intern position, you could ask a question like, if that person has worked with interns, what things did they do that you think yourself could better approach the way they did not sort of like handle things and such kind of things. You need to ask those questions. And after that, this means you've ticked all the boxes. You've asked multiple clarifying questions. You've explained your brute force solution first. You don't think optimally first. Don't think optimally first. And then you've identified the opportunity to sort of like clearly reason through the problem, analyze time and space complexity, walk through examples before coding. You wrote clean code. That means that you well commented your code, fantastic naming of variables. You've tested your solution, it works, and then you've asked follow-up questions, and then you also sort of like explain trade-offs. Like this one, um, this one this one is introducing an O of n in terms of storage, but if it's sorted, you could sort of like get an O of 1 because you'd not be introducing any new thing in terms of like the storage. And yeah, that's how you'd approach such a scenario, and that's how you'd get yourself, for example, hired for this case. So thank you for listening up to the very end. If you have any questions, feel free to reach out to Ian either on LinkedIn or on X. Yeah, and we'll get to work together. So LinkedIn is Ian Duncan. This should be it. Duncan, and then on X it's your underscore Java guy. Yeah, I'm a farmer, so you can hear those chicken crowing. Yeah, yeah. Thank you so much for listening up to this very end, and all the best in your interview. And stay tuned for the series. Have a lovely day. Bye bye.